Okay, welcome to this video where we are working on completing the square. And so what I wanted to do is show a video on a visualization of what it means to complete the square. So what we're going to start with is we gotta start with an equation here. So let's imagine that we've been given the following equation. Given x squared plus 2x equals 15. So we have basically this is standard form of the equation. And so we're going to use some actual geometric shapes here to represent the actual equation. The size of the shapes don't particularly matter. It's just a concept of what this is going to cover. So we were talking about completing the square as a way to solve the quadratic equation. It's also a way to help rewrite the equation from standard form into vertex form. And then from that information, we have our axis of symmetry, or well, from that we actually had the vertex of the equation, and then or the parabola, and then we also had the axis of symmetry as well as the maximum or the minimum that we could use or that we'll find in here. So what we'll start with is we're going to visualize what the left side of the equation is going to look like. And so we're going to use an arbitrary square to represent our x squared. Okay, so we're just going to start with creating a square. We're going to go with the 5 by 5 here, just to represent this graphically. It's not going to be pretty, but we're just doing our best here to represent it. Okay, so we have our square. And so ideally we need to understand that the length of this square is x, the height of the square is x, and therefore the area of the square is represented as x squared. Okay, so and then we're adding this rectangular piece here, this plus 2x. And so we're going to use another rectangle. Okay. And we're going to make this so it's easy to actually visualize what this looks like here. Okay, so the width of this rectangle is 2. The height is still x. And so by multiplying them, the area of this rectangle is 2x. Okay, so now let me go ahead and take out the shading on this because I'm going to need this here in a second. So I have a square of x squared. I have a rectangle of 2x, and combining this together, we get the total area of 15. And so we're going to end up adding a square component, our square constant in this video. Okay, and so we're going to try to figure out what that is going to actually look like. And so when we do this, we're going to say it equals, and we're going to create another rectangle that's going to be the same size as these two, so we see that it visually creates the same representation. And so we're going to have a 5 by 4, or 5 by 9 here. 4. Okay, and as you can see, it literally makes the total same size here. So like if I actually look at the actual sizes of these squares in this rectangle, I have 25 little squares that make up this space. I have 4 by 5, so I have another 20. So the total number I'm going to have inside here is 45, but we are saying it actually represents the area of 15. Okay, so but ideally they do represent the same space. Okay, so now we're just trying to figure out what are we adding to both sides of the equation. Well, what we're going to do is we're going to take this square again. We're going to add it down here at the bottom. So another 5 by 5. We're just going to basically duplicate what we've done up at the top, but in a way here. And then what we're going to do is we're going to take half. We're going to focus on taking half of this rectangle. Okay? So we're going to take that half and we're going to put it along the side of this rectangle. wants to keep curving it on me. Okay. Then I'm going to take the other half. So this side is also the same color. And we're going to take the other half that we had here and we're going to put it along the bottom. Okay. And so this piece, we're going to shade it in. It's also the same as the other half. So we take half of the linear component, place it along the side, and what you should notice is that there ends up being a square component that kind of just magically appears. Okay, and we'll shade this piece in here. Okay, so what we're doing is we basically said we took half of this piece. Okay, so if we think about this, this is still x along the side. This is still x, and now instead of half, or this component here is now 1, and this component is 1. So we're taking x plus 1 times x plus 1, and that ends up creating this squared component of 1 squared that we are literally adding to both sides of the equation now. So we're adding a square to each piece. Okay, we're going to copy this and we're going to paste it over here. Of course it did. So let's just redraw it. So we have literally added the square component to both sides of the equation. So this is our square constant. So in this case here, because it is 2, we're taking 1 squared that we're adding. Which is just 1 on both sides. So if we took this shape here, this rectangular shape, we could actually say, we'd just redraw it. We're going to reshape it so that we end up finding that extra piece of square here that we had. So we took x plus 1 the total area of the rectangle above, by readjusting it, doesn't actually change its total area. We just change the look of it. So we end up with the same piece. And so you can see here, or hopefully you see here at the bottom, that we literally just added this component so that we could complete the square. We took the rectangular shape and turned it into a square. So if we look at this piece here, this is our x component, whatever that is. And we end up making a new square. So this is what it means to complete this square. Hopefully this helps you out. I found that when I did the visual of this, helped me understand the process for completing the square. Made it just quite a bit simpler for me.